And then they have this. And this is literally going to be solved easy with ratios, because they're asking about the ratios. So they're saying you have this bigger circle, and the radius is 5, and the arc length, actually I'm going to put this the other way around. So that brings you to this example where you have a bigger circle and a smaller circle, and we're asked to find the arc length if they have the same central angle. So let's use the definition of radian to write this down. So I'm going to take my radians, and it says the arc length, so that's 8.84 divided by the radius is 5. So arc length, I'll show you this in a second, divided by the radius. And we want to set that same thing up for the smaller circle, which has a radius of 2.5. So if that's 2.5, then what would this be? And so notice to get from 5 to 2.5, that's half, or I divided it by 2. So 8.84 divided by 2 would give us. So it'd be 4. 4 point, because we're dividing by 2, right? 4.42. There you go. It's half of it. Woohoo. Okay, checkpoint. Okay, here is checkpoint 18. Notice there are 6 questions to this one, and the first one starts with a problem, like a modeling problem with arc length. Shelly and Jamie are trying to get around. Jamie has to get to Shelly going along that. So we have that the central angle is 123 degrees. And so we know that formula. We take the arc length, which is arc measure 123 over the whole, which is 360. Multiply it by the circumference. So the circumference is 2 pi times the radius of the circle. And it says that the radius of this one is 50 meters. So I set the problem up like this. So I did 123, because that was the central angle, over 360, so the part over the whole, I should put degrees on this also, multiplied by the circumference. So the circumference is 2 times pi times the radius. So we're just going to calculate this part right here. We don't have to put degrees in there, but we're going to calculate that with a calculator such as Desmos. So we can come here and do this. So 123, 3 over 360 multiplied by 2. I'm going to hold on to pi for a minute, because sometimes the answer has pi in it and sometimes it doesn't. Oh no, he won't want it for sure, because it wouldn't make sense to measure something with pi. So I'm going to put pi back in here. Look at 107.3377. Now let's go back to the question and see what we're supposed to answer. It says how many meters rounded to the nearest meter. So 107.33 rounds to 107. And that's all we do for that one. Okay, we have this circle A has a radius of 4 and an arc BD has a length of 6.5. If a different circle with radius 6, so let's go like this. We're going to do the same way that we did on 18.3. So we're going to take our arc length, divide it by the radius, and then set it up. So the arc length on the one that we have is 6.5. The radius is 4. And now they're saying there's a new one who has a radius of 6. We want to know what is that arc length. And there's not as, anyway, so we're going to go like this. I know that you can solve things when they are proportions using the cross product. So I would rather do it this way. So in fact, I'm going to do it a kind of a shortcut way, because I could do 6 multiplied by 6.5 is equal to 4x. I'm just going to do it this way. Then divide by 4, divide by 4. So in the calculator, I can do 6 multiplied by 6.5, 6 multiplied by 6.5 divided by 4. and we get 9.75 is our x. So 9.75. There we go. And then, so this is which statement defines the radian measure. So we just talked about this. The arc length would be L, and the radius is R, and so it's going to be the L divided by the R. That was pretty easy. Okay, this one we want to know the radius if we're given everything else. And so we're going to set this up just given the arc length. So the central angle is 146 over 360. And then we multiply that by 2 pi r, and that should equal 35.7. And I'm going to look at the answers to see if the answers had pi or no. Nope, it didn't. So we're just supposed to round it to the nearest whole number. So let me show you this again. We are multiplying all of this is one number that we're multiplying by r, so we can divide both sides by that. So r is going to equal whatever 35.7 divided by 146 over 360 multiplied by 2 pi. So we're just going to go into decimals and do that. So we have 35.7 divided by 146 over 360 multiplied by 2 pi. Oops. Over here. So 2 pi. And I get 14.00 something something. So it's just going to be about equal to 14. So about equal to 14. Coming back here, 14. Okay, question 5 of 6. We have the radius, we have the central angle, and we are supposed to find the arc length. So our central angle is 52 over 360 multiplied by 2 pi, and then our radius is 3. And then the answer, notice that these answers have pi. So that means when we're doing this, we're going to put pi in our pocket and save it for later. So we go like this. I'm going to take pi out. So pocket, put it in your pocket. So we're going to multiply in our calculator 52 divided by 360 multiplied by 2 multiplied by 3. And so we can go 52 over 360 multiplied by 2. Oops. Over to the side. Multiplied by 2 multiplied by 3. And we get that. Now watch how cool Desmos is. If you have another calculator, you can do this. If you have a TI, you can push the math button and then enter, and it should do the same thing. Click on that and it changes it back to a fraction. I got 13 over 15. So we're going to come here. We did 13 over 50. Now we're going to take the pi out of our pocket and put it up there with 13. So 13 pi over 15. Oh, I just realized I made a mistake on this. The red is what we want to find. Notice it said AQB. I did this on all the other things too. We're going to start over. Good thing I can edit. Okay, so for this one, for number 5 here, we have a central angle of 52, a radius of 3, but notice how sneaky they are. They want to find the radius of that whole thing. We want that whole thing. So normally we'd set this up. We would go the degrees over 360 multiplied by 2 pi multiplied by 3. But when we have that 52 and it's the smaller part, we're going to have to do 360 subtract 52 here first. And we'll still get everything the same. So that was the part is a bigger part divided by 360 multiplied by 2 pi by 3. And if you look at the answers here, if you look at these answers, they all have pi in them. So that means I'm going to take this pi and I'm going to put it in my pocket and figure that out later. So you'll see I actually did this problem earlier and made a mistake on it. So let me hurry and clear this out. Oops, just getting cleared up. So if you come to decimals here, we can do parentheses 360, subtract 52. Notice I didn't actually have to subtract that. I'm just going to leave it up to decimals to calculate it for me. We have that, and then we need to multiply it by 2. We're going to keep pi out because we're going to leave it in our pocket, multiplied by 3. Now look at this crazy decimal. I think that's really hard to like, wow, what's happening? Watch this. Push that button right there and it goes to a fraction. If you have a TI-84 that you're using, you can do math, frac, enter. So math, enter, enter, and then it will change it too. So we got 77 over 15, and now we need to take the pi back out of our pocket and put it right there. So 77 pi over 15. So there we go. And the last question on checkpoint 18. And this is the weird one. So they are kind of basically taking that whole formula that we had for the area, for the what the definition of pi is, which is the circumference divided by the diameter, and rewording it. So let me just kind of go over how they did that. So we have, with this picture, you have 2 circles, a bigger circle and a smaller circle. That's so bad. A, B, this is diameter 1, diameter 2. And if we were to talk about what the formula is for pi, it would be the circumference of A divided by the diameter of 1. And that would be the same thing as the circumference of B divided by the diameter of 2. But if we did the cross product on these things, we would still have equivalent statements, but it would just look like this. So we'd have the diameter of 2 and the circumference of A is equal to the diameter of 1 times the circumference of B, which it's true. What does that help you know about the circumference? I'm not sure, but that's what we're looking for. We're looking for the diameter of 2 and the circumference of A, and the diameter of 1 and the circumference of B. Weird question. Didn't help anybody learn anything. Okay, that is checkpoint 18 and all the workbooks. So good luck on getting that done. I talked fast. You can slow this video down. I hope you do. And good luck.